In topic 3 now, we're going to use some of the skills we've developed to do what is called rational equations, or equations that include fractions. So, you're going to write these out over on the other side, and I'll write them out a little bigger so we can see them better. 9 over x minus 3 equals 3 over 2x. Now, back in Module 1, we said when we had fractions in an equation, you want to multiply each term by the lowest common denominator to get rid of the fractions. And that's what we're going to be doing here. So, what is my lowest common denominator? It's going to be 2x. So we're going to multiply this by 2x, multiply this by 2x, and multiply this by 2x. Now, in doing so, we're multiplying each term by something that will get rid of the fractions. So here, the x's cancel out. Here, nothing cancels out. And here, the 2x cancels out. So now we rewrite it. This is going to be 18 minus 6x equals 3. So it looked a little daunting in the beginning. By using the technique of getting rid of all the fractions, by multiplying each term by the lowest common denominator, we've made it something rather easy. So we want to try to keep our variable positive. I'll transpose this to this side, becomes a positive 6. Transpose this to this side, this becomes a negative 3, and a positive 18 gives me 15. Then I'm going to divide both sides by 6, and I get x equals, taking a 3 out of each one, 5/2. And if you check down below, that is the answer. Now, in looking at our next example here, this is a case where things are a little bit different. Here we had 3 terms. Here we just have a fraction and a fraction. So our common denominators are actually these 2 things. But a technique we can use when we have something like this is we just cross multiply. So this will become 5 times 2x plus 3, cross multiplying this way. That's only when you have a fraction equals a fraction. You couldn't use that technique here because of this number. And then this will equal 12 times x minus 3. All right, let me give you a moment to solve this. So distributing, we get this. And then to keep my x's positive, I'll transpose the 10x, get a 2x. This becomes a positive 36, and 15 is 51. Now we just divide both sides by the numerical coefficient of the variable. And that's our answer. Again, if you have any questions, ask. Now, since these are a little small, I'll write them out, and you can write them out too. 2 over 8g minus 17 over 4g equals g over 2 minus 3. So again, to get rid of fractions, we're going to multiply every term by the lowest common denominator, which is 8g. Now we do our canceling. This cancels nicely. So we get a 2. Now 4g will go into there twice. So we have a negative 2 times 17 is a negative 34. 2 will go into there 4 times. So we have 4g times g is 4g squared. And this will be a negative 24g. Now notice what we have here. We have a quadratic equation, g to the second power. So we're going to group these, and this becomes a negative 32. I'm now going to take that negative 32 over to the other side, and I get 4g squared minus 24g plus, on this side, 32, and I'll just erase it from here and put a 0 there. Now this is a quadratic equation in standard form. How do we solve that? Well, first we want to factor out a 4 from everything. So I'm going to divide everything by 4 just to make it smaller. So this is still 0. This is going to be g squared minus 6g plus 8. Now we factor this. G, 4, 2, minus, minus. So it looks like g will be here a positive 2, and here a positive 4. And if we check our answers, that is good. So the technique, get rid of each fraction by multiplying by the lowest common denominator, getting rid of all the fractions, combining like terms, and if we have a quadratic equation, we're going to... Now, as we look at example D, we see some interesting things going on. So let me work it a little bit and then get back to you. Now, what I've done here is I've taken out of this top numerator a negative 1 and reversed the signs, but I see I have, this is going to be 4x minus 8. So I switch these two signs around by taking out a negative 1. Now notice there is a negative here. Now I have a negative of a negative will make this now a positive. So a little fiddling, that's going to save me dealing with too many signs. Now, as we see this, what is our common denominator? Well, it happens to be this. So I'm going to multiply every term, there's 3 terms, by this. So I have x times x minus 1 Multiply this one by x times x minus 1, and this by x times x minus 1. Okay, so now we have to do the actual canceling out. Here the x will cancel here, and this gives me 6x minus 6. Now nicely, all of this cancels out, and I end up with 4x minus 8 equals, again, this cancels out with a 3x. Now, using our techniques, again, much easier equation than having to deal with the fractions, we group like terms. This will be 10x minus 14 equals 3x. Now we want to keep our x's positive, so this will transpose 7x equals 14. Divide both sides by 7. X equals 2. Now, something I haven't mentioned yet, but is in our textbook, and we should mention it, is that if we get an answer like x equals 2, and if we were to put that in the denominator, and that value of 2 made our denominator a 0, then that would not be a solution. Remember, we had these qualifiers for domain. Now, every once in a while, too, we get what is called an extraneous root, which is an answer that we reject. It doesn't work. Okay, so let's go on to our last example. Now, for this one, it's in function form, but we just convert it. We go 2x minus 5 over x equals 3. So what would our common denominator be to get rid of the fractions? Well, in this case, it would be x. We're going to multiply everything by x. So here we get 2x squared. Here the x's cancel out, and we get a negative 5 equals 3x. Well, this is a quadratic equation, so we have to put it in standard form. 2x squared minus 3x minus 5 equals 0. So we factor it. Unfortunately, these aren't as difficult as some others we had. And we'll want the 5 there and a 1 there. So we need a negative 3, so this will be a negative, and this will be a positive. So to give it the full treatment, 2x minus 5 equals 0, or x plus 1 equals 0. So here this is a 5, divide by 2, 5 halves, and this is x equals a negative 1. And those are our answers. And again, we convert it from function notation into a regular equation, multiplied by each term by the lowest common denominator, got rid of the fractions, put it in standard form, factored it, and we have our answers. Okay, that'll wrap up this section.